I was knowing that you don't have access to any HPC system or means computing system kind of thing. So I don't know whether you can do this one. Maybe I saw somebody has done RT2. That poster, who is that? One poster is there na outside. I think from Bhuvaneshwar somebody they have one poster. Nissan, that they have done. So maybe he may be knowing better. So this one, what I was trying to give is it's a sort of hands-on on radiative transfer model. So why that radiative transfer? So today morning when Fiona took the class, somebody asked that why we are not assimilating the retrievals? Why only the brightness, either the brightness temperature or the direct radiance? So why we are not assimilating the retrievals? Do you know? In the initial stage when we were using 3D VAR, optimal interpolation, Cressman technique, those type of data assimilation methods, we were using the retrievals. So for retrieving the data, what we need, we need to use a background field. So that background field is coming from any of the model. So if whoever is retrieving the data provider, they use one model for retrieving the data, and they retrieve the temperature and humidity profile and they supply to other operational senders. So the operational senders may not be using the same model. They may use a different model. So for the retrieval purpose, we are using one background field. So there we have to make lot of assumptions. So one way we are adding more error in that retrieval process itself, and we are bringing the retrievals of temperature and humidity to the operational sender there where we are using different model. So the background is different. Again, we have to do the O minus B check, background minus observation. So the observation we retrieved is with another background, and here the background we are using is different. So if we use the same background field, it is okay. So the error will be less. But if we use different background field again to compare, then we are introducing more errors in that one. The error will be more. So in later on when we introduce 4D VAR and that advanced data assimilation techniques, the operational senders started using the direct observation. So direct observation means either radiance or brightness temperature. So radiance assimilation we are telling means it is the brightness temperature equivalent to that black body that we are assimilating. So it is in terms of that Planck's law, all those things, it is coming the brightness temperature. So brightness temperature is not same as the ambient temperature or the atmospheric temperature we are talking. So the brightness temperature, if we want to assimilate, so in our geophysical model, whatever the equations we are having, so equations are of temperature, humidity, wind, then like other cloud parameters, something like that. We don't have brightness temperature in the geophysical equation. So if we don't have that parameter in our equation, how we will assimilate? So brightness temperature is not a predictive variable in from any of the model. Whatever model you are running, either it is WRF or GFS or income, whatever it is, that brightness temperature is not a predictive variable. So how we will assimilate that one? In that case, how we will assimilate that variable in the model? You have learned all the data assimilation things. So the Jacobian, whatever you are telling, you are having two terms. One is the background term and the observation term. So what are the variable that coming in that observation term? H operator, that observation operator. So for assimilating any data, we need observation operator. Suppose if you are assimilating the temperature, so you need an observation operator, but in that case the observation operator is only an interpolator, because temperature is a variable, prognostic variable from the model. So you can predict temperature from the model. So whatever the observation you are getting, it may not be at the grid point. So wherever you are having observation, you have to use the observation operator. You have to interpolate the model value to the background, to the observation point. So there also you have the observation operator, but the function of observation operator is simply to interpolate the model equivalent to the observation point. But in the case of brightness temperature or GNSS arrow, that arrow we are assimilating the bending angle. Radar, reflectivity or radial velocity. So these are not predictive variables from the model. So in those cases we need an observation operator that converts the model variables to the concerned the quantity that we are having or that we want to assimilate. So in the case of satellite data assimilation, so it is the brightness temperature we are going to assimilate. So we need a observation operator that can convert the model variables like model temperature and humidity. So we have the model temperature and humidity from the model profiles or analysis background or whatever it is, we have those things, and we have the surface information also. So these profiles and variables that it has to take and convert that to the equivalent brightness temperature. So there in that H operator, whatever it is, observation operator we are telling is the radiative transfer model. So we have to use the radiative transfer equation or the radiative transfer model. So in the case of many people may be using the WRF system. So what are the radiative transfer model we are using in the WRF DA? You can select that one, that option is there. So what are the different models we are using? I think there are two options. Huh? How many are using WRF for DA? So how many are assimilating satellite data, brightness temperature? Nobody is assimilating. Okay. So, CRTM. Okay, okay. So there are two options in WRF. One is the CRTM and another one is the RTTO. CRTM is the community radiative transfer model and RTTO is again for radiative transfer model for TOWs. Like that it is coming. So here that CRTM also available, freely available. I think in the NSUB GitHub, if you see the free, the standalone CRTM you can download. So similarly, if you see the NWP SAFs, I think you know, but you are using, no? This RTTO, okay. He already used this RTTO model for insert 3D retrievals for temperature and humidity, those things. So we can go to this NWP SAF site. This is the site. So you have to register, then only you can download. So after registering, they will send that authentication mail, then you have to download the software. So if you see here, so this is the software part, whatever you are having. So you have many software here, not only RTTO. Actually, I was planning to give RTTO, but I think now anyway we cannot do any hands-on because that we don't have any system. But you can try in your laptop also if you have any Fortran compiler. So if you see that there are many software. So these are all standalone software you can play with. So you have to simply register there and download this one. So RTTO is one, AAPP. AAPP is Ayers ATOS processing package. So this is for processing the hyperspectral data like ERC, CRIS, Ayers, ATMS, all these data can be processed through AAPP. So this is another one. Then 1D var. 1D var also. So whatever the data assimilation thing we are telling 3D var, 4D var. So if you want to do only 1D var, one location, one profile, so you can download the 1D var. Everything that whatever you want to do, all the sample data is available with 1D var. So the documentation, everything is there. So you can download that also. And scatterometer data processes, so from SAC, that how they are retrieving the winds, so how that if they are getting the sigma note, how that it can be converted to the scatterometer, that wind speed and wind direction, all those things we can do that with the scatterometer data processes. Then the radiance simulator also there. So similar to brightness, temperature, how the radiance value, how much is there, that also you can do. So these are the some of the software, it is freely available in this site and you can register and download. So the RTTO, I think you can go to this site and you can see, just seeing that overview and all, you can directly see there is no issue. And documentation, all those things. And for running the RTTO, you need some coefficient files. So can you tell why do we need coefficient file? Suppose you are running inside 3D. So you are giving that coefficient file, na? Sounder or imager coefficient file you are giving. So why we are giving that coefficient file? Reduce the cost? No, that is okay, that you are doing, but why we are using? We can means compute also, na? On the go itself we can compute what are the value. So but we are not doing that one. Instead of we are using a coefficient. Okay, so actually in RTTO we have to give, suppose one channel, one instrument we are having insert 3D imager, that is a 6 channel imager, or insert 3D sounder, it is a 19 channel sounder. So each channel, what is the corresponding values? So what is the means absorbing gas? What are the temperature profile? What are the ozone profile? What are the humidity profile? All those things we have to compute for the whole globe. Then only we can, means suppose we should have a lookup table kind of thing. So there means it's this coefficient is kind of a lookup table kind of thing. It is computed in prior and it is kept on the RTTO. Here itself you can have that all the coefficient files. So if you see RTTO, then you can download the coefficients also for all the instruments. So how many instruments are now it is available, and all the past instrument also you can, similarly CRTM also you should have the coefficient file for each instrument. So in that coefficient file they include, actually they are computing the coefficient file using one LBL model, line by line model. So this one if you see, whatever we are seeing, it is like a band, it's not a single spectral line, it is a band. So if you are telling that inside 3D thing, so if you go to, there is another site, you can just go to WMO Oscar inside 3D. So if you go there, so WMO is keeping all the satellite information, that instrument wise everything. So if you go there, all the satellite in that particular INSAT series is available. So you see INSAT 3A, 3B, 3C, 3D, 3DR and 3DS. So how many satellite it is there in the INSAT series? All the satellites are there. And if you want to see what are the different instruments on board that one, suppose if you want to see INSAT 3A. So you just click INSAT 3A and see these are the instruments in that one. So you have a CCD, you have a DCS, we have SAS and R and VHRR. These are the instruments in that INSAT 3D8. So very high resolution radiometer. Then if you see, then when we went to the second generation, third generation like that, so INSAT 3D if we click, how many instruments are there on board? See, we have imager and sounder. So then if you want to know more about the imager, you can click the imager instrument and see what are the imager channels, imaging channels. So these are the imaging channels. So that's what we were discussing in the morning. The first channel, it is in the visible region 0.65 micrometer, and the second channel, it is in the short wave infrared, then middle infrared, then water vapor, then the TIR, thermal infrared channels. So if you see the spectral interval, it is not a particular one line, it is a spectrum, it is a layer. So here you see the 6.8 micrometer channel is 6.5 to 7.10 micrometer. So whatever they are writing there is the middle line. So 6.8 micrometer is the middle line. So it is a spectrum. So when we compute the coefficient, we have to compute the coefficient for each line. It is the whole layer we have to compute. So for that we use the line by line radiative transfer model. So that line by line radiative transfer model we use, it's not that everybody has to use the line by LBL model. So that as and when the satellite launches, that instrument SRF, that is the spectral response function, it is available, and with that the line by line model, they compute the coefficient and they keep. So those coefficient we can use in our either in the RTTO model or in the CRTM model. So we need the coefficient file, that is very important for running the radiative transfer model. Okay, so then actually we have to have the radiative transfer model, and we need the coefficient file equivalent to that instrument. And what we need, we have the actual observed radiance or the brightness temperature. So then we have to compute the equivalent from the model. So for that we need the temperature and humidity profile from the model, and also the surface information like surface temperature, humidity, what is the wind speed, all those, some of the parameter, and what is the satellite zenith angle, some basic parameters we need, and those things we have to supply. Then we have to run this model, and we will get the equivalent brightness temperature from the model. Then after that we have to compare with this observed brightness temperature and the model equivalent brightness temperature, and see how much difference is coming. So that's what we have to do, but unfortunately we cannot do that, but I will show in our HPC. So I have downloaded that RTTO. You can register and you can download, and if you are not able to download, please let me know, I can share the file. So here actually basically almost all the NWP models are in Fortran code. So because it is the sort of formula translation, and it is very easy to translate the formula. So that's why many, now RTTO I think they are trying to write in Python also, but it is basically Fortran but with some Python wrapper, like that it is there. So this one actually I already installed this one. So what you can do, when you download, you will get a tar file like this, whatever this RTTO, which version you are downloading, in that version you will get a tar file. Then you have to untar that one. So I am just making one directory. So you have that file there, then now you have to untar it. So you can try in your system if you can download. First you have to register, then you can try. Huh? System? Okay, okay. So it will just untar all the files. Because it is a simple tool. Suppose you want to design a new satellite instrument. You want to probe the atmosphere at different level, and you don't have such instrument operational, and if you want to design some sort of instrument like that, you can select the frequencies where it has to peak, like depending on the weighting function, or you can select from the existing instrument, like from ATOS, from ATMS, from a different microwave instrument. You can select the channel and you can make an instrument, so that if you want to see what is the impact, how much brightness temperature it can simulate, all those things. So in that way that you can use the RTTO. So it's not like that, suppose there is a working group like that RTTO. So if you have some information like that, you want this kind of instrument, you can write the channel frequency and send to those people. they will create the coefficient file and send to you. So then with that you can simulate all the data. So that RT2 group, it is means they are helping everybody. So whatever you want to supply is your channel information. So if you supply your channel information, they will generate the, and what the spectral weight you need, all those information, then they will generate the coefficient file and share with you. So it is now, so now you have to go to the build directory. So then you have to go to the make file local. So all the information is written there. So what you have to do, those things. So if you want to compile with HTF, then you have to give the HTF that path. So what, where is your HTF installed? So those information you want to give. So suppose if you don't have, you don't want to compile with HTF, then you can leave that as such. Because why we are using HTF, some of the coefficient files, mainly the coefficient files are text files. But some of the files that are in HTF format, like hyperspectral, like YASI, CRIS, AERS, these are big files, so they are keeping in HTF. That's why they are using the HTF thing. So if you don't want to change anything, you don't have to change. And then you have to go to the SRC directory. And you, before that, in the SRC directory, there is one script, RT2 compile. So this script you have to run. So this script you have to run in the SRC directory. So it is in the build directory. So go to the SRC directory and build that RT2 compile. So then if you have the Fortran, so which Fortran you are having? So depending on your by default it is G Fortran. So if you have the G Fortran, you can use that one. Otherwise you have to see this directory. There is one directory called ARC. So the architecture, it is there. So these are the compilers available: AX, debug, Cray, Fortran, KG Fortran, iFort. These are the compilers available. So by default it is G Fortran, and if you want to specify some particular thing, then you can give that ARCH equal to what is the compiler you are having. So I have G Fortran here. So then it will ask some questions, specify the required compiler. So leave blank for G Fortran, so you don't have to give anything. Then specify installation directory. So I'm giving this same directory. So, and have you updated the file? So I didn't update the file, no. For HTF thing, I didn't change anything. If you are changing, then you can give S. So then there is some Python wrapper F2 Py, so it is already there in our machine, so that's why it is detected. So but I don't want, means we can give S also, that is okay. Additional flag, no, leave. So then now okay to continue RT2 installation. So it will regenerate the make file and we will get all the executables. So now I think since you cannot do these things, what I am going to show is there is another site. This is the site. So you please go to this site, https sounding training hub, then That you can put in your laptop. This is that GUI based. There you can do. I think if you don't have laptop, you can sit with somebody who is having laptop. Because here you have to change and see. So, okay, so you have gone to that. I think there is no need of registration. You can go for select an instrument. So, this is the UMETSAT training page. They have given only these instruments and for the training purpose. And if you see METOP 1, so there is one instrument they have given, that is HIRS, that is a high resolution infrared sounder. And METOP 2 we have IRC and HIRS. And similarly you can see what are the instruments there. METOP 3 we have AMSU-A. And METOP SG is the next generation satellite. It is not yet launched. But as I told you, that if you want to design some instrument, you can design those things in advance, like what all the space agencies are doing. So similarly, this METOP SG is the next generation METOP satellite. So that is IRC NG is the next generation IRC. So that is not yet launched, but the coefficient files, everything is available. And if you have the data, temperature and humidity profile, you can simulate or you can compute what is the brightness temperature looks like from the IRC NG. Similarly, another satellite, it is MTGS. So MTGS is also not yet launched. It is the hyperspectral sounder in the geostationary system orbit. So MTG, this is IRS thing. So what you can do, any instrument you can select. So suppose if I am selecting HIRS. So this is the instrument HIRS, high resolution infrared sounder. See, so I am selecting this instrument. And you have to select profile. So I think you may be knowing that ECMWF profiles are available. So did you use that ECMWF, which profile data set you have used? Okay, okay. So when you download that RTTO package, that ECMWF profiles, that global profiles are available as part of the package. So you can use the temperature, humidity profile and the surface information from those ECMWF profiles. So here, you have selected the instrument. Now you have to simulate the brightness temperature. So for simulating the brightness temperature, what are the inputs you need? You need to provide the temperature, humidity profile and the surface information. So for that you need some temperature and humidity profile. So that you are selecting from this particular. So you just give select profile. So you have selected one profile and that map will come here. I don't know, here the net is slow. So these are the locations where that ECMWF profiles are available. So from this map you can select any profile. So you have the temperature and humidity profile from those locations. So here by default I think some profile it got selected. It is at this location, longitude -25, latitude 75.3 and surface temperature is 263.27. So this is the profile. So if you want to select some profile over the Indian Ocean, so I select this profile. Longitude is 71 and latitude is 5.7, surface is 298. So you see these are the profiles available. So the temperature profile, it is like this. So in the troposphere it is decreasing, then increasing, then decreasing, like that. This is the we know that temperature profile structure. Then we have the humidity profile also. So humidity profile also, it is decreasing humidity. So this profile, if you select, you can just see what are other profiles also. Suppose if you are seeing some profile over this region, what is the structure? Here itself you can study so many things. Like these are the profiles, what is the temperature and humidity profile over the tropics, what is the structure over ocean, what is over the poles, what is over the, what type of profile we are getting over the extra tropics. Those things also you can study here from this GUI. So if you see over this particular location, you are seeing the temperature profile like this and temperature and humidity profile like this, but if you see over this region, it is entirely different. So the atmosphere itself is different. So we have to see how, means if we are doing, if we are assimilating something, when you are computing the background, all those things, we have to take care of the location. So from the location also we are getting lot of error in the simulation. So if you want to simulate the brightness temperature at different location, the inputs are different. We have to give separate that whatever the, according to the location, the temperature and humidity profiles are varying. So here that we selected some, I selected this one. You can select any profile, whatever you want. And actually they have given for all months, and maybe for 3 dates they have given 1st, 10th and 20th. So that is there. Then temperature, humidity and surface temperature values are there. So then what you can do, see I am going to select this profile, and here also you can see what is the range, the temperature. So this is the surface temperature, it is changing from 210 to 310, means in that range it is coming. And I am selecting this profile. So I have selected profile 008 HIRS on board METOP 1. So now I am going for simulation. So when I simulate, what will I get? What are the inputs I have given? Temperature profile, humidity profile and surface temperature. So these are the inputs we required to simulate the brightness temperature for this particular instrument HIRS on METOP. So then corresponding the radiative transfer, that coefficient file, it is already taking, but we cannot see that coefficient file here, but it is taken. So I am going to simulation, go to simulation. See, this is the one, the profile I am giving. So T, Q, then T, 2 meter temperature, 2 meter humidity, and run RT-tau simulation. See, so now you have, in HIRS there are 19 channels. So again you can go to this WMO Oscar site, just see. Search for HIRS WMO Oscar. And HIRS is on board many satellite. So here we are using METOP 1. So you have to see what are the, means HIRS channels are same in all different. It is coming Nimbus, but that is the first one. So we don't need Nimbus. So METOP 1 is METOP A satellite. So METOP A is not operational now. Anyway, METOP A, B and C, the instruments are same. So HIRS 4, version 4 it is. See, these are the channels. If you see, there are total 20 channels. You can count that. So out of the 20 channels, the last one, the 0.69, it is in the visible region. So morning when we discussed, we already told From the visible channel we don't have the radiance, it is the reflectance. So we are not assimilating the that data in the assimilation system, but we can assimilate because RT2 for the visible is also there, so that also we can use. But this is RT2 for the IR and IR we are discussing, IR and microwave. So visible channel we are not assimilating. So in this case, if you see the HIRS instrument, you can see what are the channels. There are 19 channels. So when you give one profile and the temperature and humidity profile and the surface temperature and the surface humidity value, how many brightness temperature you will get? It is a 19 channel instrument. So how many values you will get? 19 channel brightness temperature we will get, because actually I should show you the coefficient file. So it is successfully installed. So then after that we can run here also, but before that I want to show the coefficient file. So this again, this is depending on the predictor and depending on the number of levels in your profile. You can have many coefficient files like 54 level, 101 level, like that, depending on the profile. That ECMWF profile we are talking about. So you can select how many levels in your profile, whether it is 54 or 101. These are the two available number of levels. You can select that one. So I am just going to. So here you are having almost all the coefficient file. So now what we are doing is METOP 1 HIRS. So we have the METOP 1 HIRS coefficient here. One for one instrument, one coefficient file. And in that all the channels will be specified. Oops. There is no power. Good. Okay, we can continue with that site, then I will see. You please tell me that site. Actually, I forgot that we were doing na? Sounding. Hmm? Train hub. Huh? Huh? What? T int. Okay. Training hub. Hmm? T. Okay. Okay. So. So any profile you can select, anyone you, I am just selecting this one and go to simulation, run it off. So you will get, means here also it is written how many channels. So you can see it is 19 channel. So corresponding to each channel you have the brightness temperature. So you see that you have given one profile, one temperature and humidity profile and the corresponding surface temperature and the surface humidity value, and you got that at that particular location what is the equivalent brightness temperature from those instrument. So similarly you please change the location and see how much difference you are getting in the brightness temperature. So you can play with the profiles. Suppose over tropics, over the extra tropics and over the poles, how much difference in the brightness temperature it is coming. That is your exercise you can do. So let me see what happened here. I think I am not getting power in this one. It's not coming. I think I can unshare this one. Define. Okay, did you try? What changes you are seeing? All are able to change, no? This is just click and play kind of thing. So another thing what you can do is, if you see the surface emissivity that it is fixed, so then you can use Atlas or model also. So if you use the model one, then again you simulate. So then you see what is the difference. So if you change the emissivity, the surface emissivity also, that also affects the BT calculation. So the surface, what kind of surface, what is the emissivity of the surface, everything it affect the BT calculation. So you can see you have two RENs, REN 1 and REN 2. So the REN 1 is with that fixed emissivity value and REN 2 is with model emissivity value. And you can see there are difference also. So what is the BT difference you are getting? So for the channel 1 to 7 there is not much difference. The BTs are the same whether we use the fixed brightness temperature, fixed emissivity or the model emissivity. But for other channels like channel 8, 9, 10 and some other channels you can see the differences also. So depending on the what type of emissivity model you, because in the whatever the model you are using, there will be an emissivity, that also we use the lookup table or the emissivity atlas, or you can use the model diagnosed emissivity value also. So that way also the computation of the brightness temperature it changes. Fixed atlas? Only two options are there for surface emissivity. Fixed and model, na? Fixed and atlas. It's okay. So no problem. So you can use atlas. Atlas one you can use. So what is Jacobian? Hmm? What? What is Jacobian? So she already explained, na, Fiona, then in her talk, what is, in the case of that RT2, what is the Jacobian? If you see the weighting function, in the case of that IR instrument, if you see the weighting function and Jacobian are one and the same. It is the top of the atmosphere radiance, whatever it is seeing the satellite. So it is, if you see, if you want to see the Jacobian, you can click that Jacobian and run it again. What is the top of the atmosphere radiance? See below you get the Jacobian matrix. So this is for each channel how much it is coming. So the it is the what is that, the brightness temperature, that gradient you are getting, dou BT by dou T and dou BT by dou Q depending on the temperature and humidity. So temperature thing and humidity thing, you can, humidity that we are not getting much, only for the water vapor channel we will get, but for the humidity thing you can see what are the temperature channels you are getting that values. So here also you can see this is the dou B by dou T, then skin, all those things it is coming. This is for channel 1 and similarly you can change and see for different channels. Don't know whether it will come. So here you can change for different channels and you will come to know where the peak information is coming, which portion of the atmosphere. So that also you can play with. Is there any issue? Everybody can do, no? Actually, you have to do yourself and see that if you change the profile, how much difference in brightness temperature you are getting for. Then you will get some idea in each region of the means globe over the tropics, how is the brightness temperature, over the polar region, how is the brightness temperature. Those type of information you will get flavor how it is coming. So this one we are telling only one profile. So if you want to simulate more means you have to give multiple profiles, that anyway you cannot do through this one. You have to download the file, means this package you have to download, and you have to give the input profiles, and then you can simulate how many means profiles you want to give, that many brightness temperature you will get at different locations.
To modify the input profile, we have to go to the first step, or we have to click here?
You have to go back. Maybe you can go to home also, you can go home. Then I can go to. Or here also, okay, that is anything. I don't know whether without, I think you have to go to home and then you have to. Then I just want to show the, what is that? Okay. So this is the coefficient file I was talking about. So this is for the HIRS instrument. So these are some information from that what are the gases, what are the first model they are using, those things, and it gives the channel information. So here we have the all channel information. So in each instrument, so this is for the IR instrument, so that IR and microwaves, there is no visible channel included. So you can have that in the WMO Oscar side we have seen 20 channels, but here you can see only 19 channels in the that coefficient file. So these are the channel number, then channel status, whether it is active or working or not working kind of thing. So all one means all channels are active. Then central wave number. So we have seen that it is not a single line, it is a layer. So what is the central wave number? So what is wave number? Wave number. 1 by lambda, okay. So that it is the inverse of wavelength, that is the wave number. So wave number it is there. So that just it is not the wavelength here, the wave number has shown. So the third column is the wave number. Then the band correction coefficient, gamma correction coefficient, like that. So whatever these information, it is coming from the line by line model. It is calculated the coefficient value for all each channel, and it is written. So every time whenever we are running the model, we don't have to compute the coefficients again and again. So it is already calculated and kept. So that's what this coefficient files. And if you see here also it is written what are the gases we are using, all those things. So in this particular thing, you see first model version, it is Atito 7 we are using in this particular computation, and number of channels are 19 and number of gases 3, and PC compatibility level, that means that principal component analysis, that is coming only in the hyperspectral instruments. So for multispectral we are not doing the PC analysis, PC compatibility. Then mixed gases, those things. So we have 3 gases, and if you see below that, everything is computed and kept. So this is the channel number and the coefficient file, all those things. And see, we have the number of coefficient per channel. All these things are coming from the line by line model. And reference profile, so how many reference profile, it is the mean of that reference profile. If it is using the ECMW of 54 set or 108 set, whatever set they are using, based on that. And means temperature, humidity, then ozone, all those things are coming. Then profile and means what is the range, that a layer thing also coming, that is what it is, envelope it is coming. And mixed gases, those things. So these are already computed and kept. So all this information is, then transmission coefficient, all those things are there. So everything, if you want to know more about this RT coefficient, that coefficient file, you can go to the NWP SAF page and you get all the information there. So all documents are there, so you get more information here. So if you see the documentation part, downloads, coefficient, everything is there, so you can get more idea about the coefficient file. And basically the coefficient file, it has all the information about all the channels. So here we have seen for the HIRS, so HIRS is the 19 channel. So basically you can see here the channel informations are there. So the 19 channel information it is coming. And similarly, if you want to see the insert 3D, some information, any of the insert. So we have insert 3 imager, insert 3 sounder, insert 3 4, means it is 3D and 3DR files are there. So depending on the position of the satellite, there will be small changes in the coefficient file also. That means insert 3D and 3DR, if the even though the instruments are same, the coefficients are slightly different because the location is different. So if you see imager, see again you can see, I'm not going to explain all the things, but you can see how many channels, the channel details are there. So as we already discussed that insert 3D imager is a 6 channel imager, and out of that 1 is in the visible and 1 is in the shortwave infrared. And for the radiative transfer computation, we have not included those 2 channels. We have included from 3, 4, 5 and 6. So first 2 channels are not there, and 3 is the middle wave infrared and 4 is the water vapor, and 5th and 6th are the thermal infrared channels. So accordingly the wave number also there. So then you can use this one, and you can use the profile water. If you are having some radio sonde at some particular location, and if you want to know what could be, what is the brightness temperature of different channels at that particular location, so you can simulate using, you can give the radio sonde temperature and humidity profile and the surface information as the input, and you can compute what is the brightness temperature. And if you have the actual brightness temperature, so you can download the actual brightness temperature, it is freely available from Mosdag site. So SAC Space Application Center Mostak site, you can register and you can download all the data. So then you see that how that observed temperature and the simulated brightness temperature, it is matching. So for each instrument, the coefficient files are very important, and we need, before computing this brightness temperature, we need the coefficient file. And similarly, if you want to see the sounder, how many channels are there in sounder inside 3D? How many? 19 channels. So out of 19, one is in the visible. So we expect how many channels in the coefficient file? 18. So you see there will be, so it is written what are the channels also. Long wave infrared like that. So we have 18 channels. So all the 18 channel information is there. So when you use this coefficient file and give one profile, means input profile, then whatever you are computing is the brightness temperature from this sounding instrument, sounder. So depending on the instrument you are selecting, that brightness temperature, that calculation, you have to give separate that coefficient file. That is what it is required. So here in this one, you have, you can do retrieval also. You can try yourself if you click the retrieval thing. So retrieval means you are giving the brightness temperature and you are means retrieving the temperature and humidity profiles. So what earlier we did was that we gave the temperature and humidity profile and we calculated the corresponding brightness temperature. Now what we are going to give is, we are giving the brightness temperature and we are retrieving the temperature and humidity profile. So that you can do yourself. So this retrieval options, if you want to do all channel, you can do for all channel. This again for HIRS, that HIRS we selected the same instrument, it is coming. So then you have to run retrieval. So you will get those information. So here you have the true field, what is the true observation, then you have the background and you have the retrievals. You have given the brightness temperature to brightness temperature. What is the brightness temperature and what is the difference? So you have some differences, the background brightness temperature. So both the ways you can do. So one is the observation operator, as she showed in her slide, that to H, in one H she wrote that it is the observation operator, but one H she wrote the adjoint model. So both the ways the observation operator acts. So when we give the temperature profile and we need to simulate or we need to estimate the model equivalent of brightness temperature, that time it is an observation operator. Then when we assimilate, again we have to convert back, because whatever model control variables are temperature, humidity, brightness temperature is not a control variable in the model. So it is temperature, humidity, specific other parameters like wind, all those things are the control variable. So again we have to use the adjoint model to convert back and do the minimization. So observation operator, it does the two way it is doing the work. One, it is giving, when we are giving the temperature profile, what it is giving, it is simulating the brightness temperature. So that is for the forward model. We have to compare and we have to see how much background error, all those things are coming. Then when it comes to the cost function minimization, it is again the minimization, it is converting back. That means from again that retrieval part is coming in that. So that's what we have, the RTTOV and the 1D var. So if you see here, you can download both the things. So you will, you can learn both the things. RTTOV is the forward operator, 1D var is the minimization. So the simple way to learn the observation operator and the minimization is you can download RT2 and you can download 1D. Everything is written, all the documentation, everything is available. So now this same thing you can repeat with another instrument. Now you have done for HIRS. So you see what will happen, you use some other instrument. You can go to the home. I don't know whether. Hmm? Okay. Maybe some internet issue. Maybe many people are using. Yeah. Huh? So then in our website also, in NCMRWF website also, you will get lot of information if you want the model guidance. So what are the model we are using? So all the details are there. If you want to see the assimilation system and what are the different types of data we are assimilating, all those things are there. And if you want the special products kind of thing, so observation, actually we do the observation monitoring for, actually at NCMRWF we run at yearly and update cycle. So yearly cycle means we run at around for 0 UTC, even though we are telling 0 UTC, we run at 7 o'clock. So there is 1.5 hour delay, 7:30 like that we run. Then afterwards at 11:30 we do an update cycle. So that means if we get some observation late, so those observation also we take into account. So the update cycle we run, and for the next cycle 6 UTC cycle, the background from the update cycle will go. So if you see the data, that anyway that I have shown all these data in my presentation, but I don't know that site is not working, so we have to again, we can again see the data what we are getting. So these things we have already seen. So this is the GNSS SARO data that we were discussing. So if you see over the Indian region, we have very less, not RO, the zenith delay. So we have lot of data over Europe and we have lot of data over Japan, but we have very less data over the Indian region. So only one. Actually, we have some data from IMD and the Survey of India, but means due to some issue that data it's not coming properly. So otherwise we have some 25 locations over the Indian region. So this is one data type, that is one important data. It is having very good impact. And this is what that our scatterometer coverage. So if you see, this is 0 UTC, we don't have much data over the Indian Ocean region. And atmospheric winds and all we already explained. And another thing I thought I will show you tomorrow, but I think since site is not working, I can show here now. This is the reanalysis portal we are having. So we have two reanalysis. Tomorrow I will give a talk about our NCMRW of reanalysis. Up to what time is this training, sir? Okay. So the reanalysis data, we have two sets of reanalysis. One is the regional reanalysis and one is the global reanalysis. So the regional reanalysis we call as IMDA. So it is the Indian monsoon data assimilation and analysis. And that initially we did that for 1979 to 2018 and we extended that to 2020. And we have lot of request from our users to continue the data, but the computation facility whatever we are having, that is a constraint. So what we are doing for the continuation from our analysis, whatever the operational run, we are generating the IMDA like product over the region and we are disseminating through this portal. So if you see, if you want to use the reanalysis data, it is the reanalysis is from 1979 to 2020. And after that it is the analysis. It is not reanalysis, but for the continuity of the data, we are disseminating those data from our analysis. So these are some details about the reanalysis. So what is IMDA? And actually many users, they are downloading the data but they are not going through whatever it is given in the website. So here we have given that some of the variables. So the IMDA like products, some of the variables are 3 hourly and some of the variables are not available. And some multi-level products are available at 18 pressure level. So for the IMDA data, that we are giving the profiles, the temperature, humidity and wind, those profiles at 24 levels. But when we change to the analysis, that after 2020, the number of levels are 18. So that we have to, means whoever is the user, they have to be careful, so that it is not as the same number of vertical levels are different in the analysis and the reanalysis. And many of the two-dimensional variables like temperature, humidity, wind, all these things are available hourly temporal resolution. And the profiles like temperature, humidity, these are available at 3 hourly. So you have 3 hourly profiles and hourly single level fields from IMDA. And similarly, we have the data set like GFS reanalysis. So IMDA is the regional reanalysis and GFS it is the global. So global reanalysis also, it is from 1999 to 2018. And this also we are continuing like analysis. So if you want the real time data, so you can get the data with 1 day lag, you can download the data from our site. So many people are running the WRF with the NSUB analysis or the forecast. So this is one another way, another data set you can use for running the model. So both IMDA and GFS that reanalysis you can use. Then if you want, there are some how to run the WRF with IMDA. So there is a README file. So how will you run the WRF model with, it is fully it is written that WRF IMDA user, how to, that README file is there. So you can See, you can download whatever the files you require to run IMDA, and you can do the analysis. Many people are using this one. So it is written. So what are the variables you want to download? 10 meter U wind, 10 meter V wind, 2 meter temperature, surface temperature, mean sea level pressure, those things. And you have to combine that one. 3 hourly field also you have to download. And there is a GitHub page. There you can see all the details are there. How will you combine all those things? So all the V table, all those things are available there. So you can run those things. Prerequisite, everything is written. So GFS, it is similar to whatever the NSUB analysis you are using. There is no change because it is almost the same system. But IMDA, the system is different, so you have to follow these instructions to run the WRF model. And if you see the data sets, I know that there are some issues in our server. So many times that users are sending the requests are in queue and they are not able to download the data. So we are facing some issues like sometimes the network issue or some connectivity issue, something like that. So if you are facing any issue in data downloading, please write to me. So we will try to resolve the issue. So that these are the main variables we are having. So IMDA hourly single level data set and IMDA 3 hourly pressure level data set, and NGFS reanalysis. So that is 6 hourly file. So IMDA you are having the hourly 2D field and 3 hourly 3D field. And for NGFS it is 6 hourly, both single field and profiles it is 6 hourly. And from NGFS you have monthly and that profile and all those data set. So initially we put that IMDA monthly mean also, but later on we removed that one. So we thought that if the user want to compute their own means, then it is good to compute that one. So it is like hourly field and single level data set it is available. So login you can do. Then and another issue we are facing now is our mail server is not working properly. So whoever is the new user, so you have to log in and you may not get the verification mail. So that is one issue. So if you are registering, you please send a mail to me so that I can active that user manually. So that's what we are doing. But soon we will transfer all these things to NIC and this issue will be resolved. But right now there is some issue that means the new user who are already means they are planning to register, that they are not getting the verification mail. And right now it is not possible to reset the password also. So if you want to reset the password, you should get the reset link. So that is not coming. So we will resolve that, but for the time being, if you are trying, you please inform me so that we can activate. So this is this one you have to register, and what are the data sets available you can see. Then you have to select, and these are the variables available. But you have to be careful that when you are submitting a request, means we are requesting that you to group the similar variables like meteorological variables you can group together. But if you are clubbing the meteorological and flex and radiation variables, sometimes it is very difficult because it has to fetch the data. So similar variables, if you can club, it would be good. And the data limit, the size limit also there. So you can give your request in small chunks like that. So you can give 10 meter, suppose if you want 10 meter you component, you can give that. And you have to select the year, which year you want. So we need to add 2024 also, it is up to 2023 only. So we will add that. You can select the day, time, those things, and which format you want, whether it is GRIB or NetCDF, and you can specify the location also. If you don't want the whole region, then you can specify the location and you can submit your request. So if you are not a user, you can register now. and I can activate your means user account. So then you can submit the request that way. So actually we want that everybody to use the data so that we will get the feedback also, and in the next reanalysis we can improve. So we know that this is not the best reanalysis available, but it is a continuous time series data. So the climate studies and climate monitoring, all those things, we can use this data over the Indian region. So then for the next step, if you get feedback from the users, it would be good for us to improve the reanalysis. So I request everybody try to use the data and give some feedback. And sir already used this data. His student Gayatri, she already used, and they published some papers also. I think I will stop now. Thank you.
Any questions? Quick questions?
If you have to, like, maximum 1 year data you can download if you're selecting to collect.
Mm.
So, but after that you have to come back again, you have to select everything again for every year. So for 20 years you have to come back and select again 20 times.
Okay. I know that actually right now we don't have any API. We are developing one. After that it would be easy. Otherwise, you are from which institute? IT Roorkee. IT. Actually, they already copied all the data.
Yeah, okay. Actually, we are only accepting.
Okay.
But for accessing that is only for caching data.
No. All the full reanalysis data they copied.
So we can use the FTP.
IIT. You are IIT.
IIT Roorkee.
Okay, that I think they NIT Roorkee. They copied. Sorry. Okay. Okay, so that I know that that some problem is there, but you try downloading, and if there is some issue, please let me know. So then you can change.
Sometimes like if you're submitting the same thing multiple times.
No, don't submit multiple times, because if one request, if it is in queue, then if you are submitting multiple query, then it won't process. Mm.
Submitted for 2000 to 2020.
Mm.
Like selecting it 20 times.
Mm.
But one or two files will be like it will be taking another 7, 6, 8 days to download.
Hmm.
For that,
Okay, actually we are also seeing these issues in our server, so we are trying to, actually the server is not under AMC, so we are not doing anything. So once the AMC is renewed, then we will means solve these issues. I know all these issues are there, but I request you try to download small chunks, maybe by year, then that would be better. Otherwise, if you can come to NCMRW, we can give all the data. And if you want some particular data, please tell us, we can keep in FTP or something like that. That also we can do.